Around the world, there is no shortage of human suffering. Poverty, diseases, violence, hurricanes, and wildfires. They are constantly plaguing humanity, and even our best efforts thus far can't address all of our needs. With all the suffering in the world, why should we spend public money on enterprise like fundamental scientific research? This is a line of thinking that's come up repeatedly throughout history. Yes, it's short-sighted in that it fails to recognize that our greatest problems require long-term investments, and that society's greatest advancements come about through hard work, research, development, and often only realized after years, decades, or generations after that investment has been made. No matter what you think, investing in science is literally investing in the betterment of humanity. In our modern world, we're often looking for instant gratification, for a near-term reward or return, and for immediate improvement. But science isn't always like that. Nuclear power wasn't harnessed for decades after the idea was first proposed. The Higgs boson was only found after over 40 years had passed and billions of dollars were invested in its search. Gravitational waves weren't found until a full century had passed from Einstein's theory to LEGO's discovery. Yet each of these achievements, along with countless others, have helped bring about the modern world, with billions of people enjoying a higher quality of life than ever before. Back in 1970, shortly after the first moon landing, a nun working to alleviate poverty in Africa, Sister Mary Gioconda, wrote to NASA and begged them to stop this frivolous waste of resources and instead use this money to benefit humanity. That letter made it all the way to Ernst Stuhlinger, then the Associate Director of Science at NASA. Stuhlinger's response was all at once compassionate and convincing, and helped convince Gioconda, as well as skeptics everywhere, to care about the value science has to offer. Now, let us look at some direct as well as indirect benefits of space exploration. First one, satellite technology. The development of artificial satellite technology was a direct result of space exploration. Since the first artificial satellite, Sputnik 1, was launched by the USSR on October 4th, 1957, thousands of satellites have been put into orbit around the Earth by more than 40 countries. These satellites are used for a variety of applications, including observation by both military and civilian agencies, communication, navigation, and weather monitoring. Space stations, space telescopes, and spacecraft in orbit around the Earth are also regarded as satellites. Do you know Google Maps? Yes? Google Maps needs GPS, which uses satellites to track your position. Another one is the Hubble Space Telescope. It is a space telescope that was launched into low Earth orbit in 1990 by NASA with contributions from the European Space Agency. It was not the first space telescope, but it is one of the largest and most versatile. Its orbit allows it to capture extremely high-resolution images with sustainably lower background light than ground-based telescopes. This enables a deep view in space, and we highly recommend looking at some of their images. Many Hubble observations have led to breakthroughs in astrophysics, such as determining the rate of expansion of the universe. Next up is the ISS, or International Space Station, in low Earth orbit that was built by 18 countries. The station serves as a microgravity and space environment research laboratory in which scientific research is conducted in astrobiology, astronomy, meteorology, physics, and other fields. The ISS is also used for testing spacecraft systems and equipment required for future long-duration missions to the Moon and Mars. Biomedical research. Beginning in 1967, NASA successfully began its biosatellite program that initially took frog eggs, amoeba, bacteria, plants, and mice and studied the effects of zero gravity on these biological forms. Studies of human life in space have augmented the understanding of the effects of adjusting to a space environment. such as alterations in body fluids, negative influence on the immune system, and effects of space on sleep patterns. Canadian Science Experiments in the Cardiovascular System examines how astronauts' blood vessels change before, during, and after the mission. The study in space helps understand heart failure and how our arteries age on Earth. These are just some of the thousands of stuff space agencies around the world are working upon. If you just take NASA, their technologies are actually being used pretty much everywhere. Even the device that you're using right now to watch this video is most certainly a derivative of the innovations that NASA has released. Among the many spin-off technologies that have come out of these space exploration programs, there have been quite a few notable achievements that came from all of this, including fields of health and medicine, transportation, public safety, consumer goods, energy and environment, information technology, and industrial productivity. I think you're starting to get the idea, but let's keep going. We got solar panels, water purification systems, dietary formulas and supplements, material science innovation, and global search and rescue systems. They are just some of the ways in which these technologies have diffused into everyday life. I cannot begin to tell you how many lives have been saved because of these technologies. Next time on Discover Zen, we will be discussing everything related to the upcoming NASA's Artemis program. Thank you so much for watching. If you liked this video, make sure to click that like and subscribe button. Let us know in the comments below what technology you think has impacted Earth most of all.